Ayo. Okay, let's try this one more time. Firstly, might be a little bit noisy. We have people in the house that are doing things. So I'm trying not to disturb them. And we're just going to deal with any noises. And that's fine. And also there's a thunderstorm going on, so I think it's going away now, but anyway, lots of noise. Hope it's not too distracting. So last time we did this. Something screwed up about my keyboard. This is pretty good. Started the stream and things are already going sideways. There we go. It just started up weird. We are turning a floppy motor on, which is not hard or that difficult of a deal. So I guess let's get to things that are more difficult of a deal, but first, some things I want to show you, which is me streaming myself. Hola, Kyle. How goes it? So check out this thing that I found. DOS 65. So this is a thing that people might be aware of, but I wasn't aware of. It's basically just a CPM-alike for 6502 processors, and supposedly they provide all the source codes. They provide documentation on how to generate a system, and it's set up like a CPM where basically you write like a set of BIOS routines, more or less, to say, you know, how do I read a sector off the floppy, how do I get a key, how do I print a character to the screen, and a couple other simple things, and then you just have DOS on your machine. So I will probably do that instead of writing Joe DOS, but that's still down the road. And who knows? I'm wondering. I mean, we've talked before about the basic situation. I'm still leaning towards in monitor, or in boot ROM basic, but this does include its own basic compiler or something. I haven't read much about this, but I ran across it and I was like, oh, this looks like it could be useful. Yeah, there's some basic something. But anyway, I still think I kind of want to put basic on the ROM, just because we will, if we try and load basic into memory, we're going to run out of memory real fast. So probably still want to keep basic on a ROM, but it's cool that that is an option, and so we may play with this at some point. Also, I'm not sure, I don't think I'll play with this tonight, but maybe sometime soon. I mean, there's a million lightweight monitors for 6502, but I found one that seems relatively easy to port over here, and it's written in CA65, so we should just pretty much be able to yank it and update some stuff and have a monitor going, which will be very useful. So that's that. But today I want to basically go through the OS Dev guide on using the PC floppy drive controller, which is exactly what's on this board here, and reset it and try and read a sector. Which, well, so here's the thing. I was going to use nope. Well, actually that is perfect. I was going to use this machine over there, which is the Dell that's on the far left. Yeah. And I was trying to boot that up, and that thing is just acting real wonky. But I was going to use that to like write a known floppy image to a floppy so that I could just try reading a sector and make sure that the data comes out okay. But we're going to have to read and write ourselves, because the IBM Think Center that's in the middle there between the two beige machines is the one that I stole this floppy drive out of. So not really usable at the moment. And I think pretty much everything else that I have with floppy drives right now are Macs, which one could theoretically use, but yeah, that'd be a pain in the butt. So we're just gonna have to try doing it all locally. Anyway, I guess I can turn that off. So we need to start with resetting the dang thing, and let's see. There is a thing on how to reset it. So we are hardware resetting it, but that just puts it in an idle state. And what you need to do after it's been hardware reset is actually do basically a software reset that gets it in a working state. And there's a couple of ways to go, but I guess... So the interesting thing is here, firstly, I don't have the interrupt line hooked up. I don't necessarily want to use interrupts. Hopefully things are fast enough here that I can get away without using interrupts. We'll see. Because I also have to basically stream data off the floppy controller as it comes in off the floppy, and if I'm not fast enough doing that, then we lose data. So that's a thing. But ignoring that for a moment, I think this seems like the right... The Corrupted Bit says there's a whole wiki for OS development? What an incredible resource. Yeah, it's hit or miss, and it's, you know, very x86 PC specific for the most part. But it exists. It's a cool place. Go on the forums. There's lots of interesting people over there. It's fascinating. But, you know, also just people working on cool, silly stuff. That tend to take themselves a little too seriously sometimes. Anyway, so this says software reset is you can do two of these things. One is with doing, you got to do delay. I don't feel like doing a delay, so I will do version 2, which is pre-calculated good value for the... What is the DSR? I know what the DSR is. Let's look for DSR. It's one of the registers. Data rate select register, really. Here we go. So firstly, that was register. Data rate select register is register 4. And in register 4, I like how it's called the data rate select register, but there's only 2, maybe 5 values in here that have to do with data rate. Anyway, I don't know why that came up, but okay, so bit 7 is software reset. So what they are saying is pre-calculate a good value for the DSR, generally 0, and OR it with that reset bit high. So basically write 80 to the register. Yeah, we can do that. Then the next step is wait for the resulting IRQ. Now, the question here is there a way for me to poll to see if the IRQ was asserted? Let's look at the documentation. I feel like that would be in a register somewhere. Doesn't look like in this register. Digital input register is not it either, which we pretty much already know. Configuration control register, no. Ah, wait, interesting. So this was the part that I actually was interested in. Let's read the actual documentation on how the reset happens. So there are 3 sources of reset: the physical reset pin, a reset generated by the DOR register, and a reset generated by the DSR register. That last one is the one that I was just talking about and going to use. But it looks like those all do the same thing. So, on entering the reset state, all operations are terminated and it enters an idle state, like I was saying. On exiting the reset state, various internal registers are cleared, and it waits for a new command. Okay. But how do I bring it out of the idle state? Ah, okay, no, so we are on the right track. So the reset pin resets everything, puts it in the idle state, and then sets the DOR reset bit, and it must be cleared by the host to exit the reset state. Okay, so hardware reset still needs a software reset. Just making sure. So the two resets are functionally the same. The DSR reset is included to maintain compatibility with the old version of the controller. Both will reset the core. Doodly 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 doo. The DSR reset clears itself automatically, while DOR reset requires the host to manually clear it. DOR reset has precedence over the DSR reset. The DOR reset is set automatically upon a pin reset. The user must manually clear this reset bit in the DOR to exit the reset state. So I wonder, since we're doing a hardware reset when this thing turns on, can we just clear the DOR bit and we're good to go? Let's do a quick test code. This computer got shut down, so now I need to reopen everything. So that's fun. But I'm thinking I will just write a quick piece of code that will clear, let's see, the DOR reset, and then see if the you can now send a command bit is cleared in the master status register. So I'm going to do that second part manually right now. Let's see. So I want to, instead of printing the motor status register like I am right now, because I don't really care about that, what I am going to do is print the contents of the, I think it's the master status register that includes the, you can send me a command now. Bit, yeah, it's bit 7, RQM, indicates that the host can transfer data. So, if I send, let's see, I think DOR that's digital output register, which I believe is the one that is the motor enables as well, that I am currently using. Yeah. And there's the reset signal. So I need to set that to 1. Okay, so that's going to be fun. Because, let's see. I guess what I want to do is, instead of just writing to 6802, I want to, let's see. Yeah, so we load motor status, which is the motor on and off thing. But we're just exclusive ORing with 1-0, and an exclusive OR will only toggle things where there's a bit. So yeah, if I actually set this motor status value to something that has the reset cleared, shoot, what bit was that? DOR, where are you, DOR? DIR, no, I hate scrolling this document, but you have heard me say that many times. You don't need to hear me say it again. Hold up. Oh, no, it is further back. DOR. It is bit 2, so I should initially set this to 2. No, 4. I know my binaries. And that will set that bit to not being reset the very first time that we write to the DOR to set the motor status. And so should take it right out of reset, and we're only toggling that drive 0 motor on bit, and that should stay in the not reset state. So that should be fine, I think. And then finally the last thing is, again, instead of printing the DOR status every time, which we were doing before, let us print the MSR status, or the MSR value, so that we can see if that yo send me a command bit comes on. Yes, MSR, it is bit 7, and MSR is read from register 4, which will be mapped at 6804. And that should be that. So now this should have the reset bit cleared, and if we look at the master or the main status register, whatever, values after we program this, it should hopefully say, hey, please send me a command. And then we can try sending in a command. If that is the case, then we can start doing stuff with it. Let me review again really quick. So it says, take it out of reset, wait for an IRQ. We're gonna use drive polling mode, but I don't know how to enable it yet. Let's see. Okay, so we have to send a configure command, I guess. Interesting. This is fascinating and confusing because it kind of says you need to, and the annoying thing is I have written a driver for this floppy chip before long ago, but I have forgotten everything. And I don't have the reference code to look at anymore. So anyway, it seems to say that you need to like send a configure command to set the floppy controller to the mode that you want it to be in, and yet you have to reset it before you can send any commands. I don't know. Maybe I'm misunderstanding that, but yeah. And I still never really found, because I didn't really look, if there is a place that I can see if it did indeed send me an IRQ without having IRQ hooked up. But anyway, let's just build this and start there, and see if it even wants us to send a command in the first place, because that was a stumbling block before. That is not what I wanted to do. Link.ps1. And while that builds, let's grab our ROM here. And oh boy, XG, yes, XG. Load. Yep, it forgot all of my information. Basic.bin. Give it the old offset. Sounds good to me. Make sure the check ID bit isn't set. Program. Yay. Okay, let's see what we see. Okay, so we should see, wait, let me check the doc. Let me check the doc, let's be dang sure. We should see, I think, a 1 in bit 8. I think a 1. A 1 or a 0 in bit 8. Let's find out. Ah, also I think that's our bit. Keep that in the back of my head. Status register A, just because we happen to pass it. There is a bit in here called interrupt pending, which probably is the one that tells us if an interrupt just happened. Good to know. Anyway, let's see. Main status, RQM. Yep, indicates the host can transfer data if set to a 1. So we're looking for a 1. We're looking for a 1. Sweet. Yeah. That seems to be right. So it's 1, 0, 0, 0, 0, 0. I'm sure that first one is just straight up garbage. But it looks like it's saying, give me a command now. I gotta stop showing you that nice picture of my other computer area. And yeah, the rest of these seem reasonable. What is DIO? Indicates the direction of a data transfer once RQM is set. So it's, if this is correct, that would make sense, because it's saying it wants us to send it data, because we haven't started a command or anything yet, so that makes sense. And then the rest of these, let's see, non-DMA. Is something we don't care about, but it looks like 0 is reasonable. And then none of the drives should be busy, and we're not sending a command yet, so 1000000000. That seems reasonable, and I am very happy to see that. So, I guess let's send it a command. I guess the first thing is probably sending it a configure command. Again, this documentation, it's really, really cool that it exists, but it's very kind of haphazard. I guess I need to send a configure command. And the proper way to issue a command, which, you know, if our code was factored correctly, would we'd have a little routine just for sending commands, but verify that RQM is 1 and DIO is 0, so basically make sure it says, hey, give me some values, which we just did, and then send the command byte, then read the MSR until it says, give me more data, and then send the next parameter. Makes sense. And then execution or result phase is next, depending on whether you're in PIO mode, which is the polling mode that I'm going to use. And the command has an execution phase. We don't have DMA, so we don't skip to the result phase. Read the master status register, verify that that non-DMA field equals 1. If it is not 1, the command has no execution phase, so skip straight to the result phase. And then I guess we just sit here and wait until RQM equals 1 again, pretty much. In an inner loop, transfer a byte in or out of the FIFO port via a system buffer, then read the MSR. Okay. Why? I don't understand why you'd need to read or write from the FIFO during execution? Blah, 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 if doing DMA. Yeah, so it's just read your result bytes. Anyway. Confusing writing. That is par for the course on OS Dev, if you were curious. At least it exists, though. After reading all of the expected result bytes, check them for error conditions, of course. We're going to do it very bare bones right now, and then we're gonna add stuff later. So, we need to configure the dang thing first. So, configure command initializes controller-specific values, the data buffer threshold value, implied seek enable, FIFO disable, polling enable, and write precomp. A good setting is implied seek on, FIFO on, drive polling mode off. I want that on. Threshold equals 8. I don't know why. Precomp equals 0. Let's see. If you enable implied seeks, then you don't have to send seek commands. Interesting. The corrupted bit says, I told a guy on Discord yesterday that I don't know anything about floppy disks because I was born after 9/11, and he launched into a whole spiel about pre-9/11 life. Not very relevant to the channel, but I thought it was kind of funny. Yeah, times have changed, man. Times have changed. I'm not used to being a millennial and also old. I think that's a new thing for all of us millennials here. Because I am like a mature adult now. And that's very strange. Okay, so... See, this is like why I'd rather just read the documentation, and I think I just will, even though this does tell me what needs to happen here. The documentation is just... the actual... this thing is written so much better. Let's see. So just use this, which I'm sure is linked in here too, but... Yeah. It has a whole section of doodly 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 doo somewhere in here. Like a table of commands, what their arguments are, all of that good stuff. In a much nicer way. In a nice table. There's a lot of stuff to configure on a floppy controller. I just have to make sure it doesn't frighten me too badly and deter me. Yeah, so these are the commands. Let's see. Read data, read deleted data, write deleted data, read track, verify, version, format track, recalibrate. Ooh, you know what might be a good way to go? What if we just try really quickly, where did it go? Just send a version command and we should always get the expected byte back. So we write, what is this? A hex 10 as a command, and then we should get back, what is this, 9? Hex 90. And if we don't get back hex 90, then the command didn't work. So that's a good test for seeing if we can, in fact, send a command. Right. Let's do that. I kind of want to, I guess, do this. Like, I don't want to just do it as I was going to say I don't want to do it in like the keyboard loop like we're doing, but I mean, why not? Why not right now? That way we can make sure the version number always comes back properly, right? Yeah, why not? So, what we're supposed to do is, let's write a subroutine. Let's just do it. JSR, and let's call it wait FDC command ready. And that will just be our little loop that waits for, sorry, just figuring out where I need to write it. So, oh lord, what did I call it? Wait, FDC command ready. Right, so this will just load A from the master status register, which was 6804. And then and that with 80. Actually, I suppose we want to check if the direction is 0 as well. Well, right now we're just going to assume, because the only reason, the only case that the direction won't be 0, which is the in direction, is if we get out of sync with the controller, and if we really wanted to check it and report an error and then like reset the whole floppy controller to put it in a known good state, like that's all a bunch of like boilerplate, you know, good practices error checking code that I'm just not going to write right now, because that's not what we're doing at the moment. Because right now our code is a hot pile of garbage on purpose. I don't know, saying on purpose is not exactly what I mean, but I think you get me. Anyway, so we will just AND it with literal 80, and then branch equal, let's see, actually branch not 0? Yeah, so branch, no, that's also not. Well, this, honestly, the assembler probably supports that nomenclature, but branch not, if they were equal, the 0 flag is cleared. Wow, I'm having trouble with this today. Branch if not equal is branch if not 0. So I want branch. Branch equal. Branch if it is 0, back to... So we're just gonna sit here, and if there is any reason that that doesn't go to 1, we're just gonna frickin' hang there right now, because we're bold and dangerous today. And that's pretty much it. When we're done with that, we literally just return... I can't remember. I'm going to keep calling that return to sender, because that's what I was calling it before. And I was told what it actually stands for, and I said, cool, cool, cool. I'm going to not say that, though. All right. So that's that. That's the first thing, is we wait for it to be ready for us to send us a command. And then when it finally is, we will load the command byte, which is, let's see, I said that was 80, right? So 80, send get version command. And then I think we do the same thing. What were they saying? You know what? You know what? I'm going to read the doc on this. I bet the doc will make much more sense than whatever somebody wrote here. It's going to be longer, but it's going to make a lot more sense. After a reset, we're in the command phase and ready to accept a command from the host. Bloody, 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 blah. Refer to the table. Duty, duty, do. Check the RQM and DIO bits. That's our little wait loop thing. Doodle-doodle-doodle-doodle-doodle-doodle-doo. It asserts it again if it needs another byte. And I guess... Let's see, I think RQM will become 1, and the direction should also become 1. All data transfers occur during the execution phase, which can proceed in DMA or non-DMA mode. Each data byte is transferred by an int or DRQ, depending on the DMA mode. So we'll see if this version command doesn't work. It's because we still need to send a configure command. Though again, if you need to set whether it's in DRQ mode or, well, actually, shouldn't there? What was the default mode? You'd think it says somewhere. I'd assume it has to start up in polling mode, right? Surely. I think we'll just assume that. That still just seems like a chicken and egg problem. Configure command can do some stuff with FIFO, blah blah blah. Stuff I don't care about. Non-DMA mode transfers from the FIFO to the host. The int pin and RQM bits in the main status register are activated when the FIFO contains some data, or the last bytes of a full sector transfer have been placed on the FIFO. So, honestly, I think I'm just gonna wait for RQM to equal 1 again and see what happens. Why not? Live a little, right? So let's go ahead and... I'm not even going to check the direction pin. Oh, wait, someone's coming for me. Let me go on mute really quick. I hear someone coming down the stairs. Here. So, minor emergency. Please stand by. I'm going to try and get back as quick as I can here. One moment. Okay, so, yeah. I hate to say I might have to call it for the day. Looks like a valve broke in our shower, so it just doesn't turn off now. Yeah, that's super cool, but it's something that I have to address, like, right now. So, sorry for people who sat through a 45-minute video just to find out that I have to step away, and I'm also very bummed because I wanted to send commands to this dang thing, but this is important, so sorry, I gotta go. Yeah. Andrew says, oh no, but I gotta get back up there and help with that. So, yeah. We'll try this again tomorrow. See ya. Love ya. Bye-bye.